Today we are going to measure distance using an ultrasonic sensor. So here we require one ultrasonic sensor, one Arduino Uno board, a breadboard and a USB cable. So this is an ultrasonic sensor. It is an electronic device that measures the distance of a target object by emitting ultrasonic sound waves and converts the reflected sound wave into an electrical signal. It has 4 pins: VCC, trigger pin, echo pin and ground. The trigger pin is used to trigger the ultrasonic sound pulses. Echo pin produces a pulse when the reflected signal is received. The length of the pulse is proportional to the time it took for the transmitted signal to be detected. First of all, place the ultrasonic sensor on the breadboard in this way. Now connect the VCC pin of the ultrasonic sensor to the 5V pin of the Arduino, the trigger pin to pin 2 of the Arduino, the echo pin to pin 3 of the Arduino, and the ground pin to the ground. Our connection is completed. Coding to measure distance using ultrasonic sensor. Open the Arduino IDE software. So here first we are going to create a variable constant int, and name of the variable is trigger, and assign pin to this variable since the trigger pin is on pin 2. Similarly, we will create another variable echo and assign pin 3 to this variable since the echo pin is on pin 3 of the Arduino. Then create another variable of type long, and the name of this variable is duration. Similarly, another long variable as centimeter, and the last one as inches. So in the setup, type serial.begin to establish the communication between the Arduino and the laptop, and give the baud rate as 9600. Here declare the trigger as the output and the echo as the input. So for that, use the pin mode function. Trigger echo is input. In the loop, first we have to write the code for triggering the trigger pin. We need to start sending the signals from the ultrasonic sensor, and for that there is the procedure. We need to make the trigger pin high for 10 microseconds. So type digital write trigger high 10 microseconds and then low. In this case, we will not use delay, but instead we will use another function, delay microseconds. Then again make the trigger pin low. The transmitter will now start sending signal continuously. Need to receive the signals, and for that we will use the pulse in function. We are receiving the pulse or the signal to the echo pin, and when reflected signals reaches back to the receiver, it will become high, so we have to make it high here. So we are going to store the received signal value in the variable duration. So type duration and then the pulse in function and make the echo pin high. Now to get the distance in centimeter, we will store the value in centimeter variable. First, divide the duration by 2 and then divide it again by 29.1. In this way, we will get the distance in centimeter. Now, for inches, in the inches variable, we will store the value by dividing the duration by 2 and then dividing it again by 74. In this way, we will get the distance in inches. Now use the serial.print function to display the distance in serial monitor, and inside the bracket first give inches serial print ln, so that each time the value comes in a new line. Again use the serial print function and in inverted comma give the unit IM. Similarly, we will do it for the centimeter. Seconds. Given a delay of 250 milliseconds, our coding is done. Now click on verify. We are given an extra packet. It's showing done compiling, that means our coding is done. It's correct, and now from tools select the Arduino Uno board and the required COM, and then click on upload to upload the code to the Arduino board. Output of measuring distance using ultrasonic sensor. As you can see, since there is no object in front of the ultrasonic sensor, our distance is increasing, but as soon as I put my hand in front of the ultrasonic sensor, the distance is reduced.